apparent height for normal incidence. Suppose this is a surface which separates two media, one, and here it has a refractive index mu. Suppose this is air and this is water, and here we have an object O, and we are seeing from this place, and the incidence is normal. So just consider a paraxial ray. This angle is very small. Then this ray gets refracted like this, and it seems to be coming from I. That means this is the object and this will be its image. So if we look from this location, then the object will appear to be raised above. So when we look from up and the object is here, it is raised up and we see less distance, and here if this is h height, if I denote this by h height, then the height h dash we have to calculate up to which this image is raised up. So let us call this A and this is B. So this is the normal, and the angle it makes with the normal is I, and here this is R. So this is I, so this becomes I, and this is R, so this ray becomes, this angle is R, so will be this angle R. So applying Snell's law, light is going from here, so 1 into sin I is equal to mu into sin R. For paraxial approximations, sin I can be approximated as tan I and sin R can be approximated as tan R. So we have sin I is AB by OB is equal to mu times AB by BI. AB cancels, so 1 by OB, OB is h height, is mu times BI, BI is h dash height, implies h dash is equal to mu h. So thus we see that if we look from the water, then the objects at certain height h will appear to be at a height of mu h. Again the apparent shift here, we can calculate this distance, that is h dash minus h. Apparent shift here will be equal to how much distance it is shifted is given by h dash minus h. H dash is mu h minus h, is that is h mu minus 1, where mu is the refractive index of this. You see, this is the case of apparent height for oblique incidence. This is my object at a height of h from this surface. Suppose this is water here and this is air. So the first image, if we see from normally, it will be formed at mu times h. This is for normal incidence. If we are seeing normally, the object O will appear to be I1, mu 1. But if I change my angle of vision, if I am here, you see this ray will further go and meet here. So the object, the image will be further raised from I1, previously it was I1 to I2, and it will shift this way. Now this happens because here as the angle of incidence is more will be the deviation, so the ray will further meet at here. So as we go here, so the image was formed here, then here, then here, and as we go further, the image will go this way, it will go. So this is how for oblique incidence the image won't be formed on this line, it will be shifted away from the eye and it will be more above this surface.